Good morning, students. In the last class, an in detail discussion about the theory of machines has been told. First, I started by saying what is theory of machines, how it has been classified. What is theory of machines? The theory which it deals with the various machines which we come across in our day-to-day life, and as well the machines which we come across in our mechanical engineering field. How it is classified? It is classified into two parts, kinematics and dynamics. What is kinematics? It is the study of relative motion between the various parts of a machine without considering the forces that are involved in the motion of each and every part of a machine. What is dynamics? It is the forces which are possible or which are responsible for the motion of each and every part of a machine. Mainly the dynamics, in which we evaluate the forces or we analyze the forces that are responsible in the motion of each and every part of a machine. Again, the forces that are possible may be either static or dynamic. Henceforth, the dynamics is again divided it into two parts, kinetics and statics. So kinetics is the one in which the forces will be evaluated or analyzed whenever a certain machine is in motion. Static is the one in which the forces will be evaluated or analyzed whenever the certain machine is in rest position or whenever a machine is stationary. With this overview about the theory of machines, I just explained in brief introduction about the different modules that are prescribed in kinematics of machines. At the end, I concluded the class by listing the different textbooks which are to be referred. Now, in the today's class, I am going to begin the mechanisms. First, to begin with, what is a machine? It is a device which receives energy and transforms it into useful work. So what is machine? It is a device which receives energy and transforms it into some useful work. In other way, we can put it, the definition of a machine like this. It is a device consists of various parts that are assembled together and working as a single unit altogether in order to give a certain specified output. In this chapter, the mechanisms of various parts from which a certain machine is assembled will be studied. So, what is mechanism? Mechanism is a combination of rigid bodies formed and connected so that they move upon each other with a definite relative motion. So what is a mechanism? It is a group of rigid bodies formed and connected so that they move upon each other with a definite relative motion. So what is a relative motion? A motion of one part with respect to the another moving part is nothing but a relative motion. Therefore, mechanism is a group of rigid bodies formed and connected so that they move upon each other with a definite relative motion. Mechanism can be done by making one of the part as fixed and the relative motion of the other parts will be determined with respect to the fixed part. So in this chapter, we are going to focus, or the point of interest in this chapter is to study about the mechanisms. Mainly the study of mechanism involves the two things. One is analysis and the other one is synthesis. So analysis is the study of motions and forces concerning the different parts of an existing mechanism. What is analysis? The study of motion and parts concerning different parts of an existing mechanism. And the second part in the study of mechanism is synthesis. Synthesis means design of various parts of a mechanism. With this, now let us start. Let us understand in detail what is meant by a mechanism. As I said already, it is a group of rigid bodies formed and connected such that they move upon each other with a definite relative motion. Now, let us quote an example. One simple example is slider crank mechanism, which is shown in figure 1. It is a slider crank mechanism, consists of rigid bodies, namely crank, connecting rod and slider. All these are shaped and connected such that they move upon each other with a definite relative motion. This is said to be a mechanism where it converts the reciprocating motion of the slider into a rotary motion of the crank. Means whenever the slider reciprocates in between the guides with the help of connecting rod, the crank will rotate about the fixed point O. So hence it is a slider crank mechanism which is mainly intended in order to convert the sliding motion of the piston into a rotary motion of the crank. Next, a machine. As I said already, it is a device which receives energy and transforms it into some useful work. Or I said another definition, it is a device which consists of various parts assembled together in order to transmit or transform a motion into some useful work. Now, the figure 1 which shows is called as a mechanism, that is a slider crank mechanism. But I want to now quote an example for the machine. Now the slider crank mechanism which is shown in figure 1 will become a machine whenever it is being used in an automobile engine by adding a valve mechanism. So the slider crank mechanism will become a machine. When it becomes a machine? Whenever it is being used in an automobile by adding a valve mechanism. On adding a valve mechanism, it will convert the available energy into a desired energy. This will yield the movement of the vehicle. So, the slider crank mechanism can be called as a machine whenever it is being used in an automobile by adding a valve mechanism. Because by adding a valve mechanism to a slider crank mechanism in an automobile, the available energy. What is the available energy in this? The force that is acting on the piston into a desired energy, that is nothing but the torque which is available on the crankshaft. So the force on the piston, which is nothing but the available energy, and the torque on the crankshaft, which is the desired energy. The conversion of the force that is acting on the piston will be into a torque that is available on the crankshaft. Together, it results the movement of the vehicle. Therefore, the same slide crank mechanism in an automobile along with the valve mechanism is said to be a machine. So, mechanism is one of the part in a machine, whereas the machine is a combination of the mechanisms. That is what the difference between a machine and a mechanism. So, what is a machine? It may be a combination of more than one mechanisms, whereas the mechanism is one of the part. Then structure. So structure is nothing but the assembly of number of resistant bodies. So what is structure? It is the assembly of number of resistant bodies having no relative motion. Then it is called as a structure. So what is structure? It is the assembly of number of resistant bodies. So what is meant by resistant body? A body which is capable of transforming the required motion with negligible deformation. With negligible deformation, if any body is capable of transmitting the required motion, then that is called as a resistant body. Therefore, the structure is the assembly of number of resistant bodies having no relative motion. Then what purpose the structure is going to be developed? The structure is meant for carrying the loads. Structure is meant for only carrying the loads. So examples for the structure are railway bridges, roof truss, machine frames. Now let us understand the difference between the machine and a structure. In machine and structure, the parts of a machine moves relative to one another, whereas in structure, the members of the structure do not move relative to one another. This is the difference between machine and a structure. What is the first difference? The parts of a machine moves relative to one another, whereas the members of a structure do not move relative to one another. Then second is, machine transforms the available energy into some useful work. In structure, no energy is transformed into useful work. Then the third difference is, the machine may transmit both power and motion. The machine may transmit both power and motion, whereas the members of a structure does not transmit power. The members of a structure transmits only forces. So examples for the machine are lathe, shaper, steam engine, whereas the examples for the structure, railway bridges, roof truss, and the frame of any machine. Then the difference between a machine and a mechanism. So as we know that machine modifies the mechanical work, whereas the mechanism transmits and modifies the motion. The second difference is, a machine is a practical development of any mechanism. Being a mechanical engineers, we can just develop a machine by converting our ideas into a reality. So it is a practical development of any mechanism, whereas the mechanism is a part of a machine. The third difference is, a machine may have number of mechanisms for transmitting mechanical power, whereas the mechanism is the skeleton, outline of the machine to produce motion between various links. So once again, lathe, shaper, steam engine are certain examples for the machine, and clockwork, typewriter, indicator to draw the PV diagrams in an engine. These are the examples for the mechanism. Then what is link? Link is also called as an element. Each part of a machine which moves relative to some other part is known as a kinematic link, or simply it is called as a link or an element. Link may consist of several parts which are rigidly fastened together so that they do not move relative to one another. So each part of a machine which moves relative to some other part is known as a kinematic link, or simply it is called as a link or an element. Example, let us take a slider crank mechanism. It consists of 4 links. One is frame, second one is crank, third one is connecting rod, and fourth one is slider. And similarly, we can take a steam engine, piston. So in steam engine, there are 4 links. Piston and crosshead is one link. Connecting rod with big and small end is a second link. Crankshaft and flywheel is a third link. Cylinder, bed plate and main bearing together forms a fourth link. But one should remember that a link or an element need not to be a rigid body, but it must be a resistant body. Therefore, the 2 characteristics where the link should possess, or it should have relative motion and it must be a resistant body. Now I will go to the different types of links. But before discussing the different types of link, I would like to recall the meaning of a link or an element. So what is a link or an element? Each part of a machine which moves relative to some other part is known as a link or an element, or is also called as a kinematic link. And what are the 2 characteristics where the link should have? Link should have relative motion and it must be a resistant body. Now, what are the different types of links? So there are 3 types of links. One is rigid link, second one is flexible link, and third one is fluid link. So these 3 links are classified based on the motion transmission. So in between the driver and the follower, in between the driver and follower, a transmission of motion is taking place, based on which there are 3 types of links. One is rigid link, second one is flexible link, third one is fluid link. So what is rigid link? It is the one which does not undergo any deformation. The name itself implies rigid. Therefore, rigid link is the one which does not undergo any deformation while transmitting a motion. Strictly speaking, rigid links does not exist. However, the deformation of a connecting rod, crank of a reciprocating steam engine is not appreciable, hence they can be considered as rigid links. Strictly speaking or practically speaking, rigid link does not exist in nature. However, the connecting rod and crank in a reciprocating steam engine, the deformation whatever is taking place can be neglected, therefore they can be considered even as rigid links. The second one is flexible link, is the one which is partly deformed without affecting the transmission of motion. What is rigid link? Which does not undergo any deformation at all. That is rigid link. Then what is now flexible link? It is the one which undergoes partial deformation without affecting the transmission of motion. For example, belts, ropes, chains and wires. All these are said to be flexible links. And third link is a fluid link. Fluid link is the one which is formed by having a fluid and the motion of transmission is taking place either through a fluid pressure or a compression. So the name itself implies it is a fluid link, means the motion of transmission will be done with the help of a fluid. That fluid may be either pressure or a compression. So the examples for the fluid link are hydraulic press, hydraulic jog and fluid brakes. And depending upon the connection, for example, if I take a link in any machine, so a certain link, how many connections it is having? So based on the connections a link is having, it is again divided into three more types. One is binary link, ternary link and quaternary link. So what is binary link? A link which is connected to other links at 2 points. At 2 points, if the link is able to connect to other links, then it is called a binary link. Ternary link is the one having connections at 3 points. Means with this ternary link, I can connect the 3 other links as it is having connections at 3 points. So what is next one? Quaternary link. So quaternary link is the one with which we can connect another 4 links to it. So the link which is having connections at 2 points, it is binary. Connections at 3 points, it is ternary. Connections at 4 points, it is quaternary. Like that, depending upon the connections where a certain link is having, they are classified like this: binary, ternary and quaternary. Binary means 2, ternary means 3, quaternary means 4. So like that, this is about a link and the different types of links. Then moving on to the another one, joint. So what is a joint? It is the point at which the links are connected. It is the point at which the links are connected is called a joint. So the different types of joints are binary joint, ternary joint and quaternary joint. Now what is a binary joint? When 2 links are joined at the same connection or at the same point, then the joint is known as a binary joint. Now the figure shows there are 4 links named as 1, 2, 3 and 4, and all these 1 and 2 are connected at point A, 2 and 3 are connected at point B, 3 and 4 are connected at point C, 1 and 4 are connected at point D. So all these, the points A, B, C and D are said to be the binary joint, because at each point the 2 links are connected. 1 and 2 are connected at point A, therefore point A is said to be one joint. What type of joint it is? Binary joint, because 2 links are connected to the point A. Like that, so it is a binary joint. Then the next one is a ternary joint. When 3 links are joined at the same point, then the joint is known as a ternary joint. Now the figure shows in which the points C and B, 3 links are joined. Hence, these joints are ternary joints. So at point C, link 1, link 3 and link 6. These 3 links are connected at point C, therefore point C is said to be a ternary joint. Similarly, link 2, link 3, link 4. All these 3 links are connected at point B, hence point B is said to be a ternary joint. Then the points A, D and E are a binary joints because at point A 1 and 2 are connected, at point D 5 and 6 are connected, at point E 4 and 5 only 2 links are connected. Therefore, point A, point D and point E are still a binary joints in this figure, whereas the point C and B are said to be a ternary joints because at each point the 3 links are connected. And next one is a quaternary joint. When 4 links are joined at the same connection, then it is known as a quaternary joint. Suppose if I add one more link, either ternary or one more quaternary, if I just joined it to the same figure, then I can identify a quaternary joint. So like this is about a joint and the types of the joint. So what is a joint? It is the point at which 2 links are connected is called a joint. So what are the 3 types of joints? Binary joint, ternary joint and quaternary joint. Next, we will move on to the kinematic pair. So what is a kinematic pair? The 2 links or elements of a machine when in contact with each other are said to be a pair. Suppose if I take the 2 links either in a machine or a mechanism, if I take the 2 links or the 2 elements, when in contact with each other, they are said to be simply a pair. Suppose if I take, suppose now I can see our students during the free time, they will go and sit they'll roam or they'll go somewhere in the place and they'll sit on the benches. One boy and one girl, or maybe 2 boys, or maybe 2 girls. So this is called a pair. So like that. So 2 links or the elements of a machine when in contact with each other are said to be a pair. If the relative motion between them is completely constrained or successfully constrained, then the pair is said to be a kinematic pair. So first of all, what is a pair? When the 2 links or the elements of a machine contact with each other are said to be a pair. If the relative motion between them is completely constrained or successfully constrained, then that pair is said to be clearly a kinematic pair. For example, in a slider crank mechanism, link 2 rotates relative to the link 1. Now let us go back to our figure 1, that is slider crank mechanism. In slider crank mechanism, there are 4 links, link 1, 2, 3 and 4, where link 1 is a frame, link 2 is a crank, link 3 is a connecting rod, link 4 is a slider. In a slider crank mechanism, link 2 rotates relative to the link 1. Hence, link 1 and 2 is said to be clearly a kinematic pair, because always the link 2, which is the crank in a slider crank mechanism, rotates or revolves about the fixed frame, that is the link 1. Hence, link 1 and 2 is said to be a kinematic pair. Similarly, link 2 is having a relative motion with link 3. Hence, link 2 and 3 is also a kinematic pair. As the crank, that is link 2, rotates, the connecting rod, which is the link 3 in a slider crank mechanism, will oscillate, will revolve. So hence 2 and 3, link 2 and 3 is said to be a kinematic pair. Similarly, link 3, that is a connecting rod, is having a relative motion relative to the link 4, that is a slider. So as the connecting rod oscillates, the slider between the guides will reciprocate. Hence, link 3 is having a relative motion relative to the link 4. Hence, link 3 and 4 is said to be a kinematic pair. Similarly, slider, that is link 4, always moves relative to the link 1, that is a frame. Hence, 1 and 2 is also constitutes a kinematic pair. Then, constrained motion. What are the different types of constrained motion? Because in the definition of kinematic pair, I told the relative motion between the two links, whenever it is completely or successfully constrained, then only the pair is said to be kinematic pair. Therefore, one should understand what is meant by a completely or successfully constrained. For that, let us discuss what are the different types of constrained motions. There are 3 types of constrained motions. One is completely constrained motion. The second one is incompletely constrained motion. And third one is successfully constrained motion. So what is completely constrained motion? The motion between a pair. Pair means it is a combination of two links whenever provided if there is a relative motion. So the motion between a pair, the motion between a pair in a definite direction, irrespective of direction of the force applied, then it is known as completely constrained motion. So when a motion is said to be completely constrained motion, the motion between a pair in a definite direction, irrespective of the direction of the force applied. In whatever the direction the force may be acting, but always the motion between the pair is in a definite direction, then it is called as a completely constrained motion. For example, if I take a steam engine, in a steam engine, the piston and cylinder will form a pair, and the motion of the piston is limited to a definite direction. Means always the piston reciprocates relative to the cylinder irrespective of direction of motion of the crank. So, in whatever the direction the crank may rotate, but always the piston will sincerely reciprocates between the guideways. So, there is a definite direction for a piston. Always the piston will reciprocate in a definite direction whether the rotation of the crank is in either in clockwise direction or anti-clockwise direction. Therefore, it is said to be a completely constrained motion. So, what is the example for the completely constrained motion? The piston which reciprocates inside the guides irrespective of the rotation of the crank. It is the example for the completely constrained motion. Similarly, we can take some other examples like motion of the square bar in a square hole. So, if I take a square bar and if I move in a square hole, so the motion of the square bar in a square hole, and similarly the motion of the shaft by providing the collars at each end in a circular hole, then the shaft will try to move in a definite direction. So these are the examples for the completely constrained motion. Then the second one is incompletely constrained motion. The motion between a pair is in more than one direction, then it is known as incompletely constrained. But whenever the motion between the links, between the two links or between the pair in only one definite direction, it is called completely constrained. But whenever the motion between a pair or whenever the motion between any two links is in more than one direction, then it is called a completely constrained motion. For example, if I take a shaft which is in a circular hole. The motion of the circular shaft in a circular hole is a best example and simple example for the incompletely constrained motion. Because the shaft is having a motion in two different directions. The shaft may rotate or it may slide in a circular hole. So therefore here the shaft may rotate or it may slide in the hole. So the motion between a circular hole and a circular shaft is more than one. It may rotate or it may slide. So it is more than one. Therefore, the motion of the circular shaft in a circular hole is said to be a incompletely constrained motion. Like that, the third one is successfully constrained motion. The motion between a pair is not completely constrained by itself, but by some other means is known as successfully constrained motion. Now, what I said about completely constrained? When the motion between the pair is having a definite direction, it is completely constrained. When the motion between a pair is in more than one direction, then it is incompletely constrained motion. Now the third one is successfully constrained. The motion between the pair is not completely constrained by itself. By itself, there is no motion between the pair. But by some other means, if the motion is taking place between a pair, then it is known as successfully constrained motion. For example, let us take a footstep bearing which is provided with a shaft. The shaft may rotate in the bearing and also it may move upward. So this motion is called incompletely constrained because the shaft may rotate or it may move up and down. So it is having more than one direction of motion, therefore it is incompletely constrained. But now I am quoting this example. I should quote this example so that you must understand what is successfully constrained. Therefore, now what I do, I will apply a load on the shaft. I will apply a load on the shaft. Then I am going to restrict the vertical movement of the shaft inside the bearing. Then the motion of the pair becomes completely constrained. This completely constrained motion is obtained by placing a load on the shaft. Therefore, this type of motion is known as successfully constrained motion. So, I am repeating once again the same example. Take a footstep bearing. Inside there is a shaft. Now, initially, the shaft may move up and down and as well as it rotate. Therefore, the motion between footstep bearing and shaft is having more than one direction. Henceforth, the motion between them is said to be incompletely constrained motion. Now, if I place the load on the shaft, I am going to restrict the vertical movement of the shaft. Then the shaft only rotates inside the bearing. Hence, the motion between the pair is said to be completely constrained. Then how the motion, incompletely constrained motion, is being converted it into a completely constrained motion? By placing a load. Therefore, this completely constrained motion is obtained by externally, by some other means. How? By placing a load on the shaft, incompletely is going to convert it into completely constrained, and this completely constrained motion is happened because of placing externally a load on the shaft. Therefore, this type of motion is known as successfully constrained motion. Some other examples like IC engine valve, piston reciprocating inside the cylinder, all these are said to be a successfully constrained motions. Now, after understanding what is pair, what is kinematic pair, and in the definition of kinematic pair, we have come across a new word called successfully constrained. Henceforth, I discussed what are the different types of constrained motions. Can anybody repeat? One is completely constrained motion, second one is incompletely constrained motion, and the third one is successfully constrained motion. Like that, these are the three types of motions. So now I am going to conclude this class by summarizing it. I started. What are all the things which we have discussed? One is machine. What is machine? What is mechanism? And what is the point of interest in this chapter? That is the study of mechanism, from which the various machines are being assembled, and what is link, what are the different types of links, what is joint, what are the different types of joints, and what is meant by a pair, what is a kinematic pair, what are the different types of constrained motions. All these have been discussed, and I am going to conclude this class